How can these two quantities be equal?
The answer can be found by looking at Newton's second law again. In the form Fnet equals ma, you can see that the units of force, newtons, must be equal to the units in which m times a are measured. The mass, m, is measured in kilograms and the acceleration in meters per second squared. Therefore a newton must be a kilogram times a meter per second squared. Thus a newton per kilogram, n/kg, is a meter per second squared, m/s2.
What is the charge and mass of an electron?
The charge of an electron is -1.602 x 1019 c, coulombs. Its mass is 9.11 x 1031 kg. Both values are known to 85 parts per billion. The electron has mass, but no size. If you direct beams of very fast, high-energy particles at electrons, they are deflected by the 1/r2 force between two charges no matter how close they come. If the electron had a finite radius, then when the incoming particle penetrated the electron, the deflection would be different.
Was this animal electricity the same as static electricity?
According to legend, the Italian physician Luigi Galvani, 1737 to 1798, was making frog leg soup for his sick wife. Whenever a nearby static electricity machine created a spark, the legs jerked. After completing several experiments, in a 1791 paper, Galvani reported that when one metal touched the muscle of a frog's leg while another metal touched the nerve, the muscle contracted. Thus Galvani helped to show that there was a connection between static electricity and electric effects in animals.
What is a reflecting telescope?
Uses a concave mirror to gather light and focus it. Uses a secondary mirror to direct light to eyepiece.
What is color blindness?
Some people are unable to see some colors due to an inherited condition known as color blindness. John Dalton, 1766 to 1844, a British chemist and physicist, described color blindness in 1794. He was color blind himself, and could not distinguish red from green. Many color-blind people do not realize that they cannot distinguish colors. This is potentially dangerous, particularly if they cannot distinguish between the colors of traffic lights or other safety signals. Those people who perceive red as green and green as red are known appropriately, as red-green color blind.
What is a position?
The location of an object. Requires a reference location, vector.
What is magnetic declination?
Magnetic declination is the angular difference between north as shown by a compass and the direction to the geographic North Pole, Earth's axis of rotation. Declination depends primarily on the location on Earth but, because the magnetic poles move, also on time.
On what does the amplitude of a wave depend?
The amplitude of a rope wave depends on how hard you shake it. For a sound wave it depends on how much compression the loudspeaker or musical instrument creates. In other words, it depends on the energy the source put into the wave. It does not depend on frequency, wavelength, or velocity.
What is Pascal's principle?
A fluid, like water, exerts the same pressure in all directions.
What is a spectrum, absorption line?
Continuous spectrum with dark gaps produced by a continuous spectrum source viewed through a cool, low-density gas.
What is conservation of energy?
The energy of the system doesn't change, energy is neither created nor destroyed. The energy put into a system equals the energy change in the system plus the energy leaving the system. True as long as no objects are added to or removed from a system, and as long as there are no interactions between the system and the rest of the world.
What is an alloy?
A metal that is a mix of two or more different metals.
In what can charge be stored?
In November 1745 Ewald Jürgen von Kleist, 1700 to 1748, dean of a cathedral in Pomerania, put a nail into a small medicine bottle and charged it with an electrical machine. When he touched the nail he received a strong shock. In March 1746 Peter van Musschenbroek, 1692 to 1761, a professor at the University of Leiden in Holland. Performed a similar experiment with the device, now called the Leyden jar.
What is a impedance matching device?
Placed between two media to create a smooth impedance transition. To maximize energy transfer by the wave through the interface. A transformer.
What is the relationship between frequency and period?
Frequency, F, is how many cycles of an oscillation occur per second and is measured in cycles per second or hertz, hertz. The period of a wave, T, is the amount of time it takes a wave to vibrate one full cycle. These two terms are inversely proportional to each other, F equals 1/T and T equals 1/F. For example, if a wave takes 1 second to oscillate up and down, the period of the wave is 1 second. The frequency is the reciprocal of that, 1 cycle/sec, because only one cycle occurred in a second. If, however, a wave took half a second to oscillate up and down, the period of that wave would be 0.5 seconds. And the frequency would be the reciprocal, or 2 cycles per second. So, you see that a wave with a long period has a low frequency, while a wave with a short period has a high frequency.
What is a screw?
Simple machine like an inclined plane wrapped around an axle.
What is an electromotive force, M/?
Potential difference resulting from separation of charges.
What are composite materials?
Modern composite materials use carbon fibers with very high tensile strength but low compressive strength to increase the tensile strength of brittle materials.
What is weight?
Force of gravity on an object, F equals mg.
What is the most aerodynamic shape?
Some think the narrower and more needle-like an object is, the lower its drag force will be. Although a needle head cuts easily through the wind, the problem emerges at the tail end, where the wind becomes turbulent and forms small eddy currents that hinder the streamline flow of air. The optimum shape depends on the velocity of the object. For speeds lower than the speed of sound, the most aerodynamically efficient shape is the teardrop. The teardrop has a rounded nose that tapers as it moves backward, forming a narrow, yet rounded tail, which gradually brings the air around the object back together instead of creating eddy currents. At high velocities, such as a jet airplane or a bullet may travel, other shapes are better. For turbulent flow, the least drag comes from having a blunt end, which intentionally causes turbulence. The rest of the air then flows smoothly over the region of turbulence behind the object.
How does heat flow by conduction?
When part of a substance is heated, its thermal energy is increased. The fast-moving atoms or molecules strike the slower-moving cooler atoms. They begin to move faster, and so gain thermal energy. Their temperature increases. The ease of conduction depends on the material. Most metals are good conductors. Even a small difference in temperature produces heat flow. Other materials are poor conductors. There can be large temperature differences without significant heat flow. In that case, one part of the substance is hot, another cold. Heat conductivity is higher in metals that have freely moving electrons. So copper, silver, gold, and aluminum are good conductors. Stainless steel is a poor conductor. In nonmetals, conductivity depends on their ability to transfer vibrations of the atoms. The conductivity of ice, concrete, stone, glass, wood, and rubber is less than 1/100 that of metals. Conductivity depends on the material, its thickness, the area it covers, and temperature difference. Light gases have better conductivity than heavier gases. For example, the heavy gas argon is used to fill the space between dual-pane windows because of its lower heat conductivity.
Are there problems with Rutherford's model?
Electrons moving in circular orbits are experiencing centripetal acceleration. All accelerating charges radiate energy. As a result, the electrons in Rutherford's atom would lose all their energy in a tiny fraction of a second.
What is the Planck's constant?
H equals 6.6 x 1034 J/Hz.
What is a circuit?
Circular path through which charge can flow. Needs a source of potential difference, wires, and a device with resistance.
What is the reverberation time?
Time for a sound to diminish by a factor of 60 dB, that is, to 1/1,000,000 of its original intensity.
What is additive color mixing?
Combining blue, green, and red light to form other colors.
What happens if you touch the Van de Graaff generator?
If you place your hands on the upper sphere while the generator is charging it, the electric charges accumulating on the sphere move onto your body as they are repelled by the other charges. When your body has enough charge, your hair may stand up on end because the electric charges on the hair repel each other. You won't be hurt because the current through your body is very small. Just don't touch anything or anyone else.
How does gravity cause tides?
As someone who lives near an ocean will know, there are 2 high tides and 2 low tides each day. They're not at the same time each day, but depend on the phase of the moon. The heights of the tides vary over the seasons as well.
What is an X-ray?
Electromagnetic wave of very short wavelength or very high energy photons. Emitted by an atom with many electrons that is disturbed by the collision with a high energy particle.
What elements beyond uranium have been discovered?
Elements 113 to 118 have temporary names until the International Union of Pure and Applied Chemistry decides on the name. The number of atoms detected in the decays of elements 113 to 118 vary between a dozen down to even 1. In the search for element 117, a total of 1019 Ca ions bombarded the Californium target and resulted in 3 atoms of element 117. Elements up through Californium 98 have been produced in milligram or gram quantities. They have been used as target materials for the accelerators that bombard them with ions in the search for heavier elements. The estimated cost of producing enough Einsteinium, 99, to be used as a target is $50 million.
Why are water towers needed on tall buildings?
A typical home requires water pressures of 50 to 100 psi. City water systems use pumps to maintain that pressure in the pipes. Vertical pipes are needed to supply the upper floors with water. Each foot of height reduces the pressure by 0.443 psi. Auxiliary pumps at various floors can provide the needed increase in pressure. An alternative is to put a large storage tank on the roof and use pumps to fill it. It then supplies the building with water under pressure due to the height of the tank. It also allows the pumps to be run to fill it at night when electricity rates may be cheaper. In addition, it provides a backup source of water in case of fire. Small towns, which often use wells as a water source, use water towers to store water in case there is an interruption in electrical service. It also allows the town to use smaller pumps because the tower can supply the pressure during peak water demands. A typical daily water use is 500 gallons per minute. But this can rise to 2,000 gallons a minute in peak times. A tower typically stores 1 day's worth of water. Water towers such as these in New York City are often placed on top of tall buildings. This way, the force of gravity supplies the water pressure needed to deliver water throughout the building.
What is an electromagnetic wave?
Electromagnetic waves consist of two transverse waves, one an oscillating electric field, the other a corresponding magnetic field perpendicular to it. Light, infrared, ultraviolet, radio, and X-rays are all examples of electromagnetic waves. All electromagnetic waves travel at the speed of light when they are in a vacuum. Electromagnetic waves are characterized by their frequency or wavelength and amplitude. Electromagnetic waves differ from other waves in that they do not need a medium such as air, water, or steel through which to travel.
Why are electromagnets, the kind that pick up junk cars, so strong?
An electromagnet is a coil of current-carrying wire wound on an iron core that is at the center of an iron cup. The magnetic field created by current in the wire is strengthened by the iron core. The strength of the magnetic field produced by such electromagnets creates a large force, as described by the Lorentz force law that allows people to more easily move large metal objects, such as steel cars, from one location to another.
What exerts this force?
If the cube is at the edge of the container, then the container exerts the force. You can check that for yourself. Use an empty fluid container, say a juice box or milk carton. Punch a hole in one side. Pour water into the container. To keep the water from leaving through the hole, you have to exert a force with your thumb. The same would be true if the hole were in the bottom.
Where are fiber optics used today?
The transmission of light information through optical fibers has had a huge impact on the technological world. The medical field has benefited greatly from the use of flexible fiber optic bundles that enable the viewing of areas of the body that would otherwise be inaccessible. Communications is probably the field that is benefiting the most from the advent of fiber optic technology. Long-distance telephone, computer, and television signals use fiber optic cables. Some systems even use fiber optics to transmit information directly to the home or business. Fiber optics can transmit large amounts of data at high speeds, permitting hundreds of television channels, very high-speed internet connections, and telephone conversations to be sent and received at the same time.
Many outlets have 3 holes. What is the purpose of each hole?
Outlets have 2 slots, one longer than the other, and a D-shaped hole. The contacts in the shorter slot are connected to a black wire. This is the hot connection that carries the 120 volts. The contacts in the longer slot are connected to a white wire, called the neutral wire. The white wire is connected to ground in the electric distribution box. Thus there is a potential difference of 120 volts across the 2 contacts. The third hole is attached to a green wire that is at ground potential.
What is condensation?
Change from vapor to liquid on a cold object.
How are modern cars designed to decrease the chance of injury in a car crash?
If your car hits a barrier or another car, it will slow or even stop. Modern cars are designed so that the front end collapses, extending the time that the forces of the barrier or other car act, thus reducing the force needed to stop the car. Cars also have airbags that don't act on the car, but on the passenger. When a sudden very large acceleration of the car is detected, the airbags are deployed. A chemical reaction within the bag rapidly fills the bag with gas. The front surface of the airbag speeds toward the passenger at speeds up to 180 miles per hour. But the momentum of the passenger is decreased slowly because he or she compresses the airbag. In addition, because the airbag has a large area, the force isn't concentrated, but spread out. This reduces the pressure on the body, reducing the chance of injury. Most recent cars also have side airbags to protect passengers from side collisions. But, airbags have caused injuries to smaller persons. Safer airbags inflate less, reducing the force on the passengers, who, because they have less mass, require less impulse to be stopped.
What official titles did Newton receive?
Newton was extremely well respected in his time. Although he was known for being nasty and rude to his contemporaries, Newton became Lucasian Professor of Mathematics at Cambridge in the late 1660s, President of the Royal Society of London in 1703, and the first scientist ever knighted. In 1705, he was famous as the master of the mint, where he introduced coins that had defined edges so that people couldn't cut off small pieces of the silver from which the coins were made. He is buried in Westminster Abbey in London.
What is thermal physics?
The study of objects warm and cold, and how they interact with each other.
What is temperature?
A quantitative measure of hotness. The more thermal energy an object has, the higher its temperature.
What are fusion weapons?
Even before the nuclear bomb was completed, some physicists at Los Alamos started work on what they called the super, a weapon based on fusion. After the war was over, there were heated discussions, both scientific and political, about the wisdom of developing a new, even more destructive weapon. Due to tensions in the Cold War, both the United States and the Soviet Union embarked on programs to create these weapons, informally called hydrogen bombs. The United States tested such a weapon in 1952, the Soviet Union in 1955. Britain, China, and France are known to have tested fusion bombs. Some aspects of fusion weapons are known while others are still secret. What is known is that the bomb starts with a uranium or plutonium implosion bomb with deuterium and tritium gases inside its core. The neutrons released by the fusion increase the fission of plutonium or uranium, boosting the efficiency of the fission device. The energy released is transferred to a lithium dihydride fusion fuel in a process that remains secret. That undergoes fusion, and the energy released causes fission in a surrounding layer of natural uranium. The Soviet Union exploded a fusion weapon that released the equivalent of 50 million tons of TNT. The most recent effort on weapons development is to decrease the size of the weapons so they can be deployed in smaller delivery rockets.
What are the two main forms of maglev transportation?
The German system uses the attractive forces between electromagnets to lift the underside of the train 15 centimeters, 6 inches, above its guide rail. The coils in the train and guide rail form a linear motor like an ordinary motor that has been unrolled. The only commercial operation is a train in China that transports people 30 kilometers in slightly over 7 minutes. The Japanese have taken a slightly different approach toward maglev technology. The track and train repel each other. Propulsion also uses a linear motor. Levitation works well at high speeds, but when starting and stopping traditional wheels must be used.
What important contributions did Nikola Tesla and George Westinghouse make in the late 19th century?
Nikola Tesla, 1856 to 1943, worked for Edison's company in Europe. Edison offered Tesla a large sum of money if he would invent an improved generator. When Tesla did, Edison refused to pay, saying he had been joking. Tesla quit. In 1884, George Westinghouse, 1846 to 1914, a prolific American inventor and businessman, formed the Westinghouse Electric Company. In 1884, 4 years later, he persuaded Tesla to join his company and purchased his patents from him. Westinghouse had improved a transformer invented in France. But Tesla's AC induction motor, invented in 1883, and three-phase generator were essential for Westinghouse's dream of transmitting electric energy efficiently over long distances.
What is a transverse wave?
Wave and its energy move perpendicular to the direction of oscillations.
What are some things you should do if caught in a lightning storm?
The safest place to be during an electrical storm is inside a building. Where you should stay away from electrical appliances such as the phone and television, as well as all plumbing and radiators or car, but if you are unable to shield yourself in this way, the following precautions should be taken. Crouch down on the lowest section of the ground, but do not let your hands touch the ground. If lightning strikes the ground, the charges spread out sideways and can still reach you. If only your feet are on the ground, especially if you're wearing rubber-soled shoes. This might limit the amount of charge that passes through your body. If you must lie down because of an injury, try to roll up into a tight ball. Take off and move away from all metal objects unless they act as Faraday cages. Refer to the question about Faraday cages. Move away from isolated and tall trees. Avoid the tops of hills or mountains and open areas such as water and fields. If out on a lake or on the ocean, get back to shore as quickly as possible. If that is not practical, get down low in the boat and move away from any tall metal masts or antennas.
What is subtractive color mixing?
combining dyes, pigments, or other objects that absorb and reflect light.
What happens to the thermal energy in the surroundings?
They get warmer, so their thermal energy increases. Then they transfer this energy to a colder object. Earth is warmer than the space around it, and so it radiates energy into space. When that energy reaches another planet or star, those objects are warmed, and so on through the entire universe.
Why is a car often the best place to be when lightning strikes?
It is not because of the rubber tires. Many people think the rubber tires of a car provide insulation from the lightning striking the ground.
What is the standard unit for mass?
The kilogram is the standard unit for mass in SI and the metric system. The kilogram was originally defined as the mass of 1 cubic decimeter of pure water at 4 degrees Celsius. A platinum cylinder of the same mass as the cubic decimeter of water was the standard until 1889. A platinum iridium cylinder with the same mass is permanently kept near Paris. Copies exist in many countries. In the United States, the National Institute of Standards and Technology, NIST, houses the mass standard, as well as the atomic clocks that define the second. The kilogram is the only standard unit that is not based on atoms or molecules. Several methods are under development to define the kilogram in terms of the mass of the carbon atom. Currently, one method has a precision of 35 parts per billion. That is equivalent to measuring the mass of your body. And the change in mass if one hair falls off your head.
What is the total internal reflection?
Occurs when a ray of light in a medium with a higher index of refraction strikes the interface between that medium and one with a lower index of refraction.
What happens to a balloon when it is submerged in water?
When an air-filled balloon is placed underwater, the water, which has higher pressure than the air, exerts a force on all sides of the balloon. The pressure from the water causes the air to compress inside the balloon. The deeper the balloon is taken into the water, the greater the pressure, and therefore, the smaller the balloon will become. The pressure from the water will compress the balloon until the air pressure within the balloon can supply an equal amount of force against the water.
Will more nuclear power plants be built?
Concerns over the buildup of greenhouse gases and the environmental problems caused by coal mining has led to renewed interest in building new nuclear power plants. Advocates of construction point out that if a standardized plant could be designed, then licensing delays could be reduced and design costs minimized. In addition, several new types of plants have been suggested and undergone small-scale testing. These promise to be simpler and safer than traditional designs. While recycling nuclear fuel is an attractive option, the plutonium in used fuel rods raises issues of nuclear weapon proliferation. The problem of long-term storage of nuclear waste still needs to be solved.
Why did Gabriel Fahrenheit define the freezing point of water to be 32 degrees Fahrenheit instead of 0?
Fahrenheit did not define 32 degrees as the freezing point of water. Instead, he defined 0 degrees as the freezing point of a water and salt mixture. Since salt lowers the freezing point of water, the freezing point for this mixture was lower than it would have been for plain water. Upon defining the degree intervals between the freezing and boiling points of the water and salt mixture, and he found that water itself freezes at 32 degrees Fahrenheit.
What are force carriers?
The photon is called the force carrier for the electromagnetic interaction. That means that, for example, the attractive force between two oppositely charged objects is described mathematically not by an electric field, but by an exchange of invisible photons. The photon has neither mass nor charge, but does have angular momentum. The gluon carries the color force which, in combination with quarks, creates the strong force. The gluon also has neither mass nor charge. The weak nuclear force is carried by the massive W+, W-, and Z degree particles. Gravity is carried by a massless particle called the graviton.
What is a lunar eclipse?
A lunar eclipse occurs when Earth is directly between the Sun and the Moon. Earth blocks the Sun's light rays from hitting the Moon, leaving it in complete darkness. For an observer on Earth, a shadow appears on the Moon, causing it to become dark. As Earth moves out from between the Sun and the Moon, the Moon is gradually illuminated until the entire full moon is seen again.
What does momentum mean in physics?
Momentum is defined as the product of mass and velocity. Momentum is a vector quantity. It has both magnitude and direction. Consider a football player, a lineman. Linemen are massive. If they can run fast, then the product of their mass and velocity is their momentum, mu. The momentum is in the direction the player is moving.
What were some of Niels Bohr's accomplishments as an exemplary physicist and citizen?
Bohr returned to the University of Copenhagen as a professor of physics in 1921. With the help of the government and the Carlsberg Beer Foundation, he established the Institute of Theoretical Physics. Bohr's institute attracted all the major theoretical physicists from around the world for short visits or extended appointments. When the Germans occupied Denmark, Bohr made a daring escape. First to Sweden, then England, then the United States. He was a consultant in the atomic bomb development effort, but after the war he tried to get President Harry Truman. 1884 to 1972, and British leader Winston Churchill, 1874 to 1965, to agree to share the secrets of the bomb with all countries, including the Soviet Union. They both rejected Bohr's proposal. But after the Soviets developed the bomb, Bohr's ideas helped found the United Nations International Atomic Energy Agency. Until his death in 1962, he worked to reduce the threat of a nuclear war. In the centenary of his birth, Denmark issued a postal stamp showing Bohr and his wife, Margrethe.
How is energy measured?
The SI unit for energy is the joule, J, but energy is often measured in other units. The calorie, cal, and the kilocalorie, kcal. Or food calorie are used both for chemical energy stored in foods and to measure heat. The British thermal unit, BTU, is most often used to measure heat in homes and industries. The kilowatt-hour, is used to measure electrical energy. A completely unofficial, but useful unit is the jelly donut. JD, the energy in a medium-sized jelly-filled donut. It helps relate all these units to a tasty treat. The table below illustrates conversions among the units. To use it, read across. For example, 1 J equals 0.239 calories, 1 calorie equals 4.186 J, 1 JD equals 239 kilocalories. In comparing fuels used to heat a home, natural gas, electricity, fuel oil, and wood, more has to be considered than just the cost of the fuel per mJ of energy. The furnaces that distribute the heated air or water have quite varied efficiencies themselves.
What is the atmospheric pressure?
Earth's atmosphere extends approximately 100 kilometers, 328,000 feet above the ground, but it gets less and less dense as the altitude increases. If the density were constant, then the atmosphere would be about 8 kilometers high, 26,246 feet. Close to the height of Mt. Everest. Some 63% of the atmosphere is below that height. The amount of force on an area of 1 square meter is about 101,300 newtons. That is, the pressure is 101.3 kPa. Atmospheric pressure varies with temperature and other conditions. Our weather is mostly influenced by high and low pressure regions, which can deviate by about 5% from normal. The pressure decreases as your altitude increases because the amount of air above you creating the pressure is smaller. At an altitude of 3 kilometers, 10,000 feet above sea level, the atmospheric pressure is about 70% of what it is at sea level. At 100 kilometers it is 3/millionths of the sea level pressure.
What is white noise?
Roughly equal sound intensities at all frequencies.
Why is it dangerous to operate electrical devices in bathtubs, showers, and over full sinks?
Although water reduces the resistance of the human body and thus makes it more susceptible to electrical shock, it is the plumbing that is the main hazard. Take, for example, a person who likes to watch a plugged-in TV while sitting in the bathtub. If the TV is not connected to a GFI protected circuit and fell into the tub, the water would come in contact with the 120-volt wires in the TV. With the metal plumbing of the tub connected to ground, the grounding path would cause a current through the water. Unfortunately, this translates into a bad day for the bather. An MP3 player or battery-powered smartphone is much safer.
Why are dams thicker at the bottom than at the top?
Dams hold back bodies of water, and water pressure increases with the depth of the body of water. So the pressure from the water pushing horizontally on the dam is greater at the bottom than at the top. If holes were bored near the bottom, middle, and top of a dam, the longest horizontal stream of water would fire out through the bottom hole because the water pressure is greatest there.
What is a direct current, DC?
Charges travel only in one direction.
What happens in a parallel circuit if more bulbs are added?
In a parallel circuit the current goes through separate branches. If another branch is added with another bulb, the current has an additional path to take. But, the battery, or generator, produces a constant voltage. So the current through the original bulbs does not change, and neither does their brightness.
What is loudness?
Measure of how a listener responds to intensity of sound. Measured in sones.
Why do some athletes go to high elevations to train?
Runners have always trekked to the mountains of Colorado to train in higher elevations because of the lower atmospheric pressure that the mountains provide. Since the air is not as dense as it is at lower elevations, the lungs need to work harder to supply the body with a sufficient amount of oxygen. Many athletes feel that training in such conditions gets their bodies used to lower amounts of oxygen. Therefore, when running in a competition at lower elevations, they can compete quite well because their bodies are used to working hard to get a great deal of oxygen.
What are the frequency limits of the human ear?
The ear allows humans to hear frequency ranges between 20 Hz and 20,000 Hz. But it is most sensitive to frequencies between 200 Hz and 2000 Hz.
What is a gold alloys?
"24-karat gold is pure gold. 18-karat gold has 18 parts gold and 6 parts other metals. 10-karat gold has 10 parts gold and 14 parts other metals.
Is there a highest temperature that can be achieved?
Although there is an absolute zero temperature, there is no highest temperature. The highest temperatures achieved to date have been from nuclear explosions, where the temperature can reach as high as 100 million kelvins.
What were some early ideas about light? Does light travel at a finite speed or is it infinite? Is light emitted by the eye or does it travel to the eye?
These questions were debated for centuries. In ancient Greece, Aristotle, 384 to 322 BCE, argued that light is not a movement. Hero of Alexandria, 10 to 70 CE, said it moves at infinite speed because you can see the stars and sun immediately after you open your eyes. Empedocles, 490 to 430 BCE. Said it was something in motion, so it must move at a finite speed. Euclid, 325 to 265 BCE. And Ptolemy, 90 to 168 CE, said that if we are to see something, light must be emitted by the eye. In 1021 Alhazen, Ibn al-Haytham, did experiments that led him to support the argument that light moves from an object into the eye, and thus it must travel at a finite speed. At the same time, al-Biruni noted that the speed of light is much faster than the speed of sound. The Turkic astronomer Taqi al-Din, 1521 to 1585, also argued that the speed of light was finite, and that its slower speed in denser objects explained refraction. He also developed a theory of color and correctly explained reflection. In the 1600s, the German astronomer Johannes Kepler, 1571 to 1630, and the French philosopher, mathematician, and physicist René Descartes, 1596 to 1650, argued that if the speed of light was not infinite, then the Sun, Moon, and Earth wouldn't be in alignment in a lunar eclipse. Despite this misconception, Kepler, in his 1604 book, The Optical Part of Astronomy, essentially invented the field of optics. He described the inverse square law, the workings of a pinhole camera, and reflection by flat and concave mirrors. He also recognized the influence of the atmosphere on both eclipses and the apparent locations of stars. Willibrord Snellius, 1580 to 1626, discovered the law of refraction, Snell's law, in 1621. Descartes used Snell's law to explain the formation of rainbows shortly thereafter. Christian Huygens, 1629 to 1695, wrote important books on optics and proposed the idea that light was a wave. Isaac Newton's 1642 to 1727, celebrated experiments using a prism to separate white light into its colors, led to Newton's theory of colors published in 1672. He recognized that telescope lenses would cause colored images and invented the reflecting telescope using a concave mirror that would not have this fault. Newton believed that light was made up of very lightweight particles, or corpuscles. In 1665, a publication by Francesco Grimaldi, 1618 to 1663, described how light could be diffracted when passing through thin holes or slits or around boundaries. In 1803, Thomas Young's, 1773 to 1829, experiments with 1 and 2 slits demonstrated the diffraction and interference of light. Augustin Jean Fresnel, 1788 to 1827, and Simeon Poisson, 1781 to 1827, did both theoretical and experimental work that firmly established the wave theory of light in 1815 and 1818. Isaac Newton used a prism to separate white light into a spectrum, leading to the publication of his findings in his Theory of Colors, 1672.
What is a cone?
cone-shaped nerve cells on the retina that can distinguish fine details in images. Located predominantly around the center of the retina called the fovea, responsible for color vision.
How is an eclipse a shadow?
An eclipse is created just as any other shadow, by the presence of an object in the path of light. In a lunar eclipse, Earth blocks the sun's light illuminating the moon. In a solar eclipse, the moon keeps the sun's light from reaching Earth. Thus the shadow of the moon on Earth is what we call a solar eclipse.
Which of the three arrangements shown below would have the properties of a refrigerator magnet as described above?
The top two wouldn't, because both surfaces would act as a magnet. The top right-hand arrangement would be a very weak magnet on both faces, because the alternating poles would essentially cancel each other out. In the third drawing, the sheets have been folded and then pressed together so that the poles are at only one surface. So only that surface would act like a magnet. The alternating N and S poles attract steel and stick to it. You can check this idea by taking two refrigerator magnets and holding the magnetic surfaces together. And then try sliding one over the other. You'll find that they skip as first N and S poles touch each other and attract. Then the like poles try to touch each other but repel, making the magnets skip.
Who invented the lightning rod?
Although a Russian tower built in 1725 had what would now be called a lightning rod, credit is usually given to American inventor Benjamin Franklin, 1706 to 1790. He invented the lightning rod in 1749 to protect houses and tall trees from being destroyed by lightning bolts.
What is a vector quantity?
A quantity that has both a magnitude and a direction.
What is a calorie?
Heat, like work, processes that transfer energy, is measured in the joule, a unit named after James Prescott Joule. Although the joule is the international standard for measuring energy, heat flow is often measured in calories. A calorie defines the amount of energy needed to increase 1 gram of water by 1 degree Celsius. The energy required for 1 calorie is 4.186 joules, which is a relatively small amount of energy. Nutritionists also use the term calorie to describe the amount of energy a particular food can provide a person.
Why does the gravitational field depend on the distance from its center?
This is not an easy question to answer. Newton recognized the problem and had to develop a new mathematics, the integral calculus, to solve it. His argument, simplified, can be illustrated with a wooden button. Hold it at arm's length in front of a window so you can see a tree. Note how much area the button covers on the tree. According to Newton, assuming that the button and tree were made of the same material, the force of attraction of the button on you is exactly the same as that of the part of the tree the button covers. The reason is that the effect of the button being closer is balanced by the much larger mass of the International Space Station orbits at about 320 kilometers above Earth's surface.
What is an anode?
Positive electrode or terminal on, e.g. a battery, electrolytic cell, or cathode ray tube.
How much water does a ship need in order to float?
Not a lot of water is needed to keep a ship afloat. Just enough so that it can displace enough water to equal its weight. Therefore, if a ship were to enter a canal that was just a bit larger than the size of the ship's hull, it would float as long as there was a small film of water around the entire hull of the ship.
What is the speed of sound?
In air about 340 mph or 760 miles per hour, at 20 degrees Celsius. Increases by 0.6 meters per second for every degree Celsius increase in temperature. V equals 331 m/s, 1 plus 0.6 T, where T is measured in Celsius.
Why does sound diminish as you move farther from the source?
Sound waves do not travel in a narrow path, but spread out into the surrounding medium as spherical waves. As long as the energy in the sound doesn't change, the power per unit area decreases as the area increases. In some cases, there is some transfer of the sound's energy into thermal energy of the medium. Thus, there can be some loss of sound energy with distance, but this loss is usually small.
When a car makes a turn, what applies the centripetal force on it?
The road supplies this force. The road is in contact with the tires, and friction between the tire and road is necessary for the force of the road to be exerted on the car. If the road is covered with ice, The friction often isn't large enough and the car goes straight, rather than along the curve. A racetrack is often banked so the tilt of the track can supply at least part of this inward force, reducing the need for friction. If you're sitting in the car, there must be a sidewise force on you so that you stay with the car as it makes the turn. Usually the friction between you and the seat is sufficient. But sometimes you have to hold onto the door handle to exert more force.
What is a lunar eclipse?
Occurs when Earth casts its shadow on the Moon. Earth must be directly between the Sun and the Moon.
What happens when a magnet is cut in two pieces?
When a magnet is cut, the atoms within the domains remain aligned. In almost every case, the cut would be between two domains, leaving aligned domains in the two halves. If you cut a domain, you would create two smaller domains, each with a north pole and a south pole. So no matter where you cut, the result is two magnets, each with its own north and south pole. The more domains, the stronger the magnet.
What is tensile strength?
Maximum tension force that can be applied without breaking object.